Have you ever wondered why understanding different types of queues in data structures is so crucial? In the realm of computer science, queues are more than just lines at the supermarket. They're fundamental data structures that help us manage and manipulate information. Queue variations such as circular queues and double-ended queues play a significant role in solving complex problems in programming and data management. These variations aren't just for show, they each bring unique benefits to the table. Circular queues, for example, maximize resource utilization, while double-ended queues offer unparalleled flexibility in data manipulation. In essence, understanding these queue variations is akin to gaining new tools for your programming toolbox, tools that can make the difference between an efficient algorithm and one that's not quite up to par. So, are you ready to expand your programming horizons? Let's delve into the world of circular queues and double-ended queues and see what sets them apart. So, what is a circular queue? Picture a classic queue data structure, but with a twist. In this variation, the last element points back to the first, forming a circular structure. This ingenious design prevents any wastage of space in the array-based implementation of a queue when elements are dequeued and newer ones are enqueued. Now, let's dive into the operations of a circular queue. Firstly, we have the Enqueue operation, which adds an element to the rear of the queue. Imagine standing in line at a bakery. You represent a new element, and the queue is our circular queue. As you join the line or queue, you are essentially being enqueued at the rear. Next, we have the dequeue operation. This removes and returns the element at the front of the queue. Following our bakery analogy, when a customer at the front of the line is served and exits the line, they are being dequeued. The isEmpty operation checks if the queue is empty. It's like looking at the bakery line and seeing no customers waiting. The isFull operation, on the other hand, checks if the queue is full. This would be like a bakery line that has reached its maximum capacity and cannot accommodate more customers. Then we have front or peek. This operation retrieves the element at the front of the queue without removing it. It's like peeking at the first customer in line without serving them. Similarly, the rear operation retrieves the element at the rear of the queue without removing it. This would be like peeking at the last customer in line. In terms of implementation, circular queues can be efficiently handled using arrays. If you're a Python aficionado, you're in luck, because implementing a circular queue in Python is a breeze. Now that we've explored the circular queue, let's turn our attention to another intriguing structure, the double-ended queue. Next up, we have the double-ended queue, often referred to as dequeued. This isn't your ordinary queue. Imagine a line of people, but unlike a traditional queue where you can only join at the back and leave from the front, in a dequeued, you can join or leave from either end. This versatility opens up a world of possibilities for its application. Let's delve into the operations that make a dequeued so unique. Firstly, we have the insert front operation. As the name suggests, this allows us to add an element right at the front of our deck, sidestepping the conventional back of the line rule. Similarly, we have the insert rear operation, which adds an element to the rear, just like in a standard queue. But the dequeued's flexibility doesn't stop there. The delete front operation enables us to remove an element from the front of the deque, while the delete rear operation allows us to remove an element from the rear end. This means we can manipulate our deck from both ends, making it a highly adaptable data structure. Now, just like with any queue, it's essential to know whether it's empty or not. The isEmpty operation checks this for us. And of course, we have the front and rear operations, or as some prefer to call them, peek front and peek rear. These allow us to retrieve the element at the front or the rear of the deck without removing it, giving us a peek at what's at the ends without altering our deck. So what makes a deck stand out? It's the ability to efficiently implement both stacks and queues. Need to add or remove elements from both ends interchangeably? No problem, a deque has got you covered. Evidently, deque is a versatile data structure, given its ability to insert and delete elements from both ends. Whether you're coding a new algorithm or solving a complex problem, understanding how a deck works can open up innovative solutions and streamline your process. Now that we've explored both circular queue and deck, it's time to put them side by side. A circular queue, as we've learned, is a clever twist on the conventional queue data structure. It forms a circle by having the end point back to the start, thus preventing any wasted space when we dequeue and enqueue new elements. This makes it an excellent choice when we're dealing with a fixed size queue. On the other hand, a double-ended queue or dequeued is a versatile data structure that allows us to insert and delete elements from both ends. This flexibility makes it the go-to option for a wide range of applications, such as implementing both stacks and queues efficiently. But let's dive a little deeper. When would we choose one over the other? Consider a scenario where we need to manage a fixed-size queue, perhaps in a system that handles requests. Here, a circular queue would be the ideal choice. Its circular nature ensures that we can always enqueue a new element as long as we've dequeued an old one, thus maximizing the use of our fixed-size array. But what if we have a use case that requires more flexibility? Perhaps we need to handle a list of items with the ability to add or remove items from both ends. This could be, for instance, in a system that handles a list of tasks with different priorities. Here, a deck would shine. With its ability to add or remove items from both ends, we can easily manage our tasks with high efficiency. To summarize, a circular queue is a great fit for managing a fixed-size queue, while a deck offers the flexibility of inserting and deleting elements from both ends. Your choice between the two would largely depend on your specific use case. Despite their differences, both circular queue and deck play a vital role in efficient data management. It's all about understanding these data structures, their operations, and when to use which. With this knowledge, we can design efficient algorithms and solve a variety of real-world problems. Despite their differences, both circular queue and deck play a vital role in efficient data management. Let's recap what we've learned about circular queue and double-ended queue. We've journeyed through the intriguing world of these two queue variations, unraveling their unique characteristics, uses, and pivotal roles in data structures. We kicked off with the circular queue, a clever twist on the traditional queue. Its distinguishing feature is that the last element circles back and points to the first, forming a neat, efficient loop. This ingenious design resolves the issue of wasted space in array-based implementations of queues. When elements are dequeued and new ones are enqueued, the circular queue ensures that no space is wasted. When the rear pointer hits the end of the array, it just wraps around to the start. We explored the key operations of a circular queue, which include enqueue for inserting elements at the rear, dequeue for deleting and returning the front element, and functions to check if the queue is empty or full. We also looked at how to retrieve the front and rear elements without removing them. We delved into how circular queues can be implemented using arrays, and even touched on a basic Python implementation. Then we shifted gears to the double-ended queue, or dequeued, a truly versatile data structure that allows both ends to be used for insertion and deletion of elements. This unique flexibility opens up a range of applications, making it possible to implement both stacks and queues efficiently. We dove into the main operations of a dequeued, which include functions to add and remove elements at both ends, check if the deck is empty, and peek at the front and rear elements without deleting them. We examined how dequeues can be implemented using various data structures such as arrays, doubly linked lists, or circular arrays, and even discussed a basic Python implementation using a doubly linked list. Both the circular queue and double-ended queue are crucial variations of the basic queue data structure. The circular queue shines in efficiently managing a fixed-size queue, while the deck stands out with its flexibility in handling elements at both ends. Remember, understanding these queue variations is not just about knowing their definitions, but about leveraging them to create efficient and effective solutions in your programming journey.